Hello, everyone. Thank you for tuning into this All About Data episode. As we start our conversation, I acknowledge that this conversation is being held on the traditional lands of the Birigal people, and I pay my respects to the elders past, present, and emerging. I'm really excited about my guest and the topic of conversation today. My guest today is a representative from the Commonwealth Scientific and Industrial Research Organization, also known as CSIRO or CSIRO for short. CSIRO is a leading Australian government agency responsible for scientific research, and it works with leading organizations around the world. So without further ado, I welcome my guest, Dr. Joseph Antony, Data Team Lead at CSIRO. Welcome, Dr. Joseph. Would you please say hello to our audience and tell us a bit about yourself and your role at CSIRO?
Hi, Barsha. Thanks for having me here. So I'm the team lead for research and corporate data here at CSRO. The team is spread all over Australia. We service a wide variety of use cases, projects, and make sure the business of, delivering science in CSIRO flows smoothly in the back end.
Perfect. Thank you, Dr. Joseph. When I think of CSIRO, what comes to mind is scientists and research, and you've touched on that. Really intelligent people and teams of those intelligent people working together across various sectors that could be economic, environmental, and social, and really the results that they bring about, which have real benefit to Australia and to the world for that matter. If I could request, and if you could share with us, would you be able to tell us about some of the exciting projects that you and your team at CSIRO are working on?
So we help support the scientists at the front end, right? With their scientific, projects, etc. So essentially, the digital support infrastructure. And some of the very interesting projects we work on are helping the data acquisition of information from satellites. We help with marine platforms which go out to the Antarctic Ocean, and we help with um, devices in farms and those sorts of settings. And that's just the gamut of what we work on.
Yeah. Wow. You know, I did start the conversation saying this is going to be exciting. I didn't realize it would be this interesting. You've mentioned projects on satellite in the sky to ships in Antarctica, marine, and helping farms, right? So if, perhaps, let's break it down to those specific use cases and talk about them. So let's start with the satellite use case. Could you tell us a bit more about that project? What's happening? Um, and because we are in this platform when we're talking all about data, could you tell us how data is collected and when we consider each of those use cases? Let's start with the satellite one.
So it's really exciting. So there's an observation platform called NOVASAR. So SAR, synthetic aperture radar, allows you to actually peer day and night through cloud, right? So unlike optical, this is not impeded by weather, etc. So it's quite unique. So NOVASAR, CSRO has access to 10% of the satellite, and what this allows us to do is essentially image Australia systemically, get a baseline of um, landscapes, understand the before and after a bushfire goes through, for example. And my team, we work with the Space and Astronomy business unit to help them acquire the data, bring it on-prem, work with it, derive products, which will then inform, various endeavors. So one of the nice things about synthetic aperture radar is it tells you about ground deformation.
Mhm.
So there's a body of work that happens in Perth modeling aquifers, right? So you can actually, down to a couple of centimeters, figure out how the Earth is moved.
Oh,
So
wow.
this allows us, so this is like a sovereign capability for Australia,
Yeah,
and it's a national facility. So,
yeah.
Australian researchers can book time, and then there's the mechanics of scheduling the observation, making sure that data is brought back in
Mhm.
all the way back till a paper is produced or policy decision is made.
Wow, that's so exciting. I mean, we saw how it looked as well, which is really cool. So all of that data from, and 10% is what I heard as well, of access to that satellite to look at all of Australia and to be able to see even, beneath the ground level how Earth may have moved, if it has. Just that's really intense, right? And it would be awesome to understand the impact of that study as well. Would you want to share with us what does that mean? What does that data mean for that use case, and how is it used? Who uses it?
So the specific case here is figuring out how you could actually recharge aquifers under Perth, for example,
Hmm.
and being able to, firstly, you need to get a baseline of
Yep.
how, the terrain looks like, and then you monitor.
Hmm.
So this then helps inform policy around what you need to do actually in terms, frequency of injection, etc. So there's a lot of
Oh,
science that goes behind this in
yep.
terms of, validating the models, but also being able to run the compute against the data. So the setup that we currently have, the data, we need to, the folks who manage the platform, you need to schedule observations. The schedule will then will go through our mission partner.
Hmm.
The schedule gets uploaded onto the satellite. It then does its observation path. It then downlinks this. So this currently happens in the UK. So we
Yep.
then have a schedule process which will actually pull the data from the UK to currently AWS Sydney. We do
Yep.
some processing there. We then bring the data back on-prem.
Yep.
And then, the scientists who've requested that piece of data will actually work on, analysis toolkits for that.
Wow, that's amazing. And we'll probably, have follow-up questions or follow-up discussions on this. But let's move on to the second use case, the marine use case and the ships in Antarctica. Tell us more about that.
So with that particular use case. So CSIRO operates for the nation, what's called a Marine National Facility. So the Marine National Facility is used by various organizations. So in this particular case, we've got the Australian Antarctic Division, and that's the RV Investigator, and it's like a platform for the nation to go and carry out research in the Southern Ocean. So the Southern Ocean is I guess the engine for the world's climate. And
Hmm.
specifically here in this body of work, they've actually looked at monitoring krill, so the smallest creatures in the ocean, which form the basis of the food web, right? And
Hmm.
understanding the health of the fisheries, etc. So um, the RV Investigator is based out of Hobart. It goes all the way out to the Antarctic, and here, that you can see the various sampling processes that happen. So you can essentially think about, towed sonar. You've got instruments that need to capture salinity information. Um, Effectively, how do you get all of this information from the ship?
Hmm.
Um, Sonar, the ship's got radar, etc. You need to fuse all of this for various um, scientific modeling purposes, etc. So the focus here will be capturing this data on the ship. You need to make sure this is done in a reliable manner. And then the folks that manage the MNF need to actually think about how to get this data off of the ship on land,
Yep.
carry out quality control before this is then given out to the end users, the scientists that came on board,
Yep.
Australian Antarctic Division, others, etc. And then we have this data housed in what's called the Data Access Portal in
Hmm.
CSIRO
Yep.
for wider dissemination.
Yeah. Wow. So what I heard was, ships doing research and scientific work, making sure we've got enough data to look at the smallest creature in the food chain. So but then how does that impact the whole ecosystem? Probably not just marine ecosystem because we're all connected, right? So it's that's just amazing, like where it starts and how, we as human beings generally going on about our day, we don't think about what the research and the amount of work that's being put in to make sure we understand the ecosystem properly, and look at the impact if anything changes. And a group of scientists like yourselves and your teams are actually looking at the data, going, making sure everything's fine. If not, what do we need to do? That is just so amazing. Thank you for sharing that. Do you have anything else to add to that?
It's really an interesting platform where this is the case where it's an extreme case of being at the edge, and you need to
Mhm.
bring the data back to the core, right?
Yeah,
One of the exciting things in this role is just the diversity of challenges that we've got to face, right? In
yeah,
helping our business units in CSRO meet these digital challenges. So there's this sort of consistent focus, right? So previously, folks would have had to have notepads, etc.,
yeah,
capturing this. How do you digitize this? How do you have provenance for this data, bringing it back in so that you
yeah.
can essentially, reliably bring all of this back for these longitudinal studies that need to occur.
Yeah, yeah. So what I heard was really, use of digitization technology to transform the existing ways we work and we do research. Right. That's
Correct.
amazing. So let's move on to the third use case that you brought up earlier on. Farming. Tell us more about what's happening in the farming industry that you guys are involved in, and what are you doing there?
So our the agriculture and food business unit do a lot of work, transformational research work to, help in Australia's food security, helping farmers in terms of farming practices, etc. And for me, the eye opener, I had an opportunity to go to a research farm called Burrawa, that's just outside here of Canberra, and what was interesting there is the digital aspects of farming. It was an eye opener to see precision agriculture in flight, right? Um, you've got tractors with GPSs in there to figure out, farmers will have to have like a plan when you're going to be planting these seeds. And we have greenhouses here where folks will actually work on breeding newer types of wheat, canola, etc., which will then get field tested in Borowa. It's essentially agriculture has gone digital. How do you fuse various data aspects? So in this clip, we're seeing some of the work that happened from our soil science area, where there was sensor technology. The chameleon water sensor, and here it's this very simple card which you actually insert moisture sensors, and then you attach it to this card to actually help end users in remote farming settings, etc., or even in developing countries understand um, how do I not overwater plants, etc. So it's applied research from CSRO that's now gone out to the world. So that was one example.
Yeah,
Um, the other example we have, for the Burrovo case is where LiDAR is actually used. So, we're familiar with LiDAR in terms of self-driving cars. So,
yeah,
so in this platform, what you're going to see is the Phenomobile, and this was work done here at CSRO, looking at how you can actually, and that's a clip of Burrowa, where you've got field plots where they carry out the analysis of various types of crops, etc. And a lot of field work needs to happen. So you can understand, right? You've got these
hmm,
devices where people
yeah,
capture readings. How do you then get this data on the edge, bring it back to the core? So
yeah,
mobile platforms like this are quite interesting because you are understanding the phenotypes,
yeah,
the growth of the plant. So this is essentially a LiDAR-based platform where they're actually capturing um, physical aspects, right? So you can
yeah,
actually get a point cloud of how the seedlings grow. So
yeah,
it's not just figuring out the actual moisture levels, etc., or even say nutrition content, the nutrients that go into the soil. This is essentially understanding the growth of the plants in
hmm,
space and time. You then create a time series data, and then the bigger problem is, okay, this is out at a farm. How do you bring it
yeah,
back to where high performance computing
yeah,
is needed to then do analysis of the point cloud? You then try to
yeah,
figure out properties, right? This
yeah,
particular type of seedling or family of seeds, how do they propagate? How do they work? How do you track the data from that? to then come up with IP analysis, etc., and then going back to farmers, how do you actually use these newer methodologies of managing soil to improve yields?
Yeah. Wow. Like it's so exciting. When we think of farms, we think of farms and vegetables and all of that. We go to Woolies or Coles and pick up our groceries there. But to look at to hear how much effort is going in to make sure everything is harvesting, or there's processes in place so they actually work, so it kind of it has an impact to the wider world. That is so amazing. And the use of technology, you
Yes.
know it's
Um,
amazing.
Yep. So science has gone digital for us, and being in the data team, it's fascinating where it's the impact. Working with our various business units, it's really this is the best job ever, I'd say, Sarah, where we help our scientists in grappling these challenges. How do you handle these large volumes of data? And a practical example, as you pointed out, Barsha, is from paddock to plate, right?
Yeah.
It's a complex process. How do you capture, all of the intermediate steps,
Yeah.
analyzing the data?
Yeah.
It's really an
Oh,
exciting time.
I know, and it was music to my ears when you said, this is the best job in the world. It definitely sounds like it. Um, so it's so great. Hey, so we're looking at the satellite data and the data from the ships and the farming, and there's it's happening. It's got to happen in a very continuous manner, right? Because you're
That's right.
actually monitoring it, and so and it is all data that's coming in, and you're monitoring via the data that you collect. So how how fast is data growing?
Wow. For us at the moment, rough figures are 30% compounded growth, right? It's
Wow.
huge. So this
Yeah.
puts immense pressure in terms of technical floor space. How do you manage data center floor space?
Mhm.
Efficiencies.
Yep.
It's a massive problem. So it's trying to drink from a fire hose, making
Yep.
sure that you work with business units to assess the value of the data,
Mhm.
and efficiently use the storage, and compute, etc. Because budgets are finite. How do you work within what we have, efficiently, effectively? It's a huge ongoing challenge. So
Yep.
you've got constant processes to think about, capacity planning, making sure that we're actually meeting needs, uptimes, right?
Mhm.
Resiliency. Yeah,
Yep.
so all of these sort of come together, and
Yep.
the good thing here is focusing on how you can deliver on that science output, mask all of the complexity of the IT. We work with our scientists to sort of get to that end state.
Yeah. Yeah. Awesome. I mean, it's so quite a lot, 30% increase. At the rate of 30%, that's heaps of sorry, that's growing really fast. And um you pointed out a very good point. It's about managing that capacity, looking at your resources. How are you most effectively using your resources and not wasting anything, to make sure, like, because there's so much demand, you got to make sure there's savings but also no wastage as well. And at NetApp, we're very humbled and we feel very proud to be working with customers like yourselves, right? And as you have experienced NetApp, the technology that NetApp has kind of helps underpin that uh, that overall data strategy, that could have that could contribute to availability, integrity, security, and probably mobility of data. That in a way, creating that data fabric across multiple environments that our customers like yourselves have created, right? So it's really great to have been able to partner with you guys in that strategy, in the impactful projects that you make happen. So in this use cases and in our conversation, we touched on collecting data at the edge, using it, maybe store it at the edge for some time, bring it back to the core, or even bring it back to a cloud maybe, and then to the core, and then maybe perhaps use uh, core for that computational or analytics, or even perhaps send it to the cloud for analytics as well. um, with so much moving parts, what is the importance of maintaining performance and high availability of your infrastructure, if you consider these projects?
Wow. It, it, yeah, that's a really good question. Um, Uptime is vital for us because being able to ensure the users of our infrastructure have confidence in the central IT to sort of provide that capability is vital. So making sure that we use resilient architectures, best practices, etc. It just comes to the fore, whereby we leave the heavy lifting to um, vendors as such, and we focus on the scientific value add, because outages essentially imply deadlines are not met, and then this has flow-on effects in terms of delivery of our projects. So that uptime aspect is critical here at Saro.
Yeah. Well, okay, so uptime is very critical. Clear, very clear. So what happens if there is an outage? What's, of there is a lack thereof of availability and performance? What's the impact then?
So it'll essentially affect our science delivery.
Mhm.
Not being able to so effectively, we have a life cycle planning process in Cyro from the start of a
Yeah,
project to delivery,
yeah,
and these delays compound that delivery for our industrial partners, our government partners. So
yeah.
reducing outages by having resiliency, replication, those sorts of storage techniques, for example, will help in partnership
Mhm.
in that sort of uptime delivery for our end users.
Yeah, perfect. Thank you. Um, one more question around that. So we talked about availability, performance. How do you maintain data security and privacy?
So CSRO is works on shoring up our internal security through various processes, and working with our cybersecurity team. Um, it's vital because it gives assurance to our partners that we are a trusted
Mhm.
entity to work with. So meshing together good IT practices along with security practices comes together in the delivery of these digital storage platforms.
Yeah.
And this then essentially allows secure provenance, helping with that end-to-end delivery.
Yeah, perfect. Thank you so much. This conversation has been so amazing, Dr. Joseph, and I got so much out of this. I'm sure the audience listening to this would be completely, blown away by the amount of information and the work that goes on into the projects that you guys are working on. And to think that when I'm a scientist, the image that comes to mind is of people in white lab coats, and it's and we still need those people. We probably have still we not just probably we still have those people, but it's really refreshing to see how science and research is more than a lab and people in white coats. um, so you, you know do you have something to add to that aspect, and how that perception could still exist?
So science has gone digital, and there's sort of like a silent revolution going on almost in terms of um, the change in how we analyze data, being able to use electronic lab notebooks,
Mhm.
essentially bringing all of these inputs in, which then goes into ensemble models, machine learning. So we've got the whole gamut from climate modeling, deep learning, etc. And how do you essentially mesh all of these technologies together to make sure that we can deliver these high impact outcomes for our end users while doing this in a secure manner. That's the challenge that we're sort of, constantly grappling with, challenging ourselves, and essentially then helping advance science. So yes, you're absolutely right, Barsha. Science has fundamentally changed in terms of, digital processes, managing data, curating data, and then delivering on that outcome.
Yeah, absolutely. And so, I that whole transformation through digitization and acceptance and use of technology, and we've actually heard of use cases and projects that are using that, and that's probably just a small subset of the big, the big picture that you guys have in plan. So thank you so much for sharing that with us. um, this has been so amazing, such an amazing conversation. Do you have any examples to share around, creativity and research through digital? Like, we talked about really big projects, but are there, part of CSIRO, are there projects that, a university student could kind of think, oh, I could do that, or I could give it a go, like, does it have to be big, big satellite or marine use cases or flying drones? Are there more accessible kind of, research and projects that other people go, hey, I could contribute to that?
We've got a whole citizen science, body of work that happens. Yeah, we're a huge organization, right? Spread across multiple geographies. So we have multiple initiatives to, reach out to um, budding scientists.
Mhm.
We have various projects, programs to help bring science to high school, various forums, right? So it's not just the big sort of instruments, etc. Even citizen science. So we
Mhm.
have something called the Atlas of Living Australia, right, which
Yeah.
is an internal sort of CSIRO-led initiative which looks at sourcing citizen science outcomes. So there are projects where kids would, go on a nature walk, like, your wonderful backyard there, right, snapping, little critters or even creatures, right, and then reporting it back because then this helps in terms of biodiversity
Oh,
analysis. What's the population of, a particular rare frog or beetle, etc. So it's wide and varying, and the accessibility essentially implies that um, you find rare creatures, from just going out, for a walk in your
yeah.
backyard. So yeah, so that's the amazing thing right now, where you as an end user can actually contribute to these projects.
Yeah. Oh, this is so amazing, Dr. Joseph. I think you painted such an amazing picture of the whole body of CSIRO and how you're running projects from small scale to the largest scales that we can think about, but how it all ties to the impact of living or human beings or creatures or, world in general, which kind of is that whole 360-degree view of the world. So it's been such a refreshing conversation, like so much insight for me, from the leaders in the industry about the transformation that you guys are making happen, not just going through but making happen. So thank you so much for this conversation. What is one last thing that you want to leave our audience with today?
um, Teams, working in a team. So it's amazing how, the diversity of opinions, cultures, people coming together to then contribute to a mission, right? That's the amazing thing here at SARO, where we come together to sort of, help in these national missions for the country and the world.
Wow, thank you so much. And on that note, thank you, Dr. Joseph, and we'll speak soon again.